Okay, good afternoon, dear students. Today we will solve a question of uniform convergence, and we will check the uniform convergence of a question with the help of rate of convergence. Okay, this is another method for understanding and verify the uniform convergence of a sequence of function. Let us take an example. Suppose that we have a function fn x equal to 2x upon n. 2x upon n. Okay, and uh, n belongs to the set of natural number, and let x belongs to between 0 to infinite. Okay, and we want to check the rate of convergence. We want to check the uniform convergence for this question. For understanding this, the first function f1x is 2x upon 1. 2x upon 1. Second function f2x is 2x upon 2. Third function f3x is 2x upon 3. And similarly, we have f4x 2x upon 4. Clear? And the graph of all the functions are, suppose this is 0, infinity, and this axis is y-axis, or we can say that this is fx, this is x. Okay, in first question, when x equal to 0, then this is 0, it means the point is here. Suppose the points are 1, this is 2, 3, 4, 5, 6, 7. Similarly here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When x equal to 0, then this is 0. When x equal to 1, then f1x equal to 2. When x equal to 1, then f1x equal to 2. It means the point is here. When x equal to 3, then f1x equal to 6. Sorry, when x equal to 2, then f1x equal to 4. It's mean 1, 2, 3 and 4, the point here. So the graph of this function is this. Clear? Similarly, for f2x, it means this is equal to x. When you cancelled out at 2 by 2. When x equal to 0, then 0. When 1, then 1. When 2, then 2. When 3, then 3, and so on. The second graph is this. Similarly, for third, when x equal to 0, then 0. When x equal to 1, then it is equal to 2 upon 3. It's mean 0.6. The graph is start from this point, and the graph of the third function is this. Okay, this is the graph of first function f1x. This is the graph of second function f2x. This is the graph of third function f3x, and similarly this is the graph of fourth function f4x. Next graph is f5x, f6x, and so on. Okay, when we approach n tends to infinity. Okay, when we approach n tends to infinite. Clear? Suppose that f100x equal to 100 equal to 2x upon 100. Okay, the graph is near about the 0 axis or the real line, near about the real line. It's mean the convergence of all the functions toward the 0 function. This is the 0 function. This is the line of 0. This is the line of 0. It's mean the function of this line is fx equal to 0. This is the line of 0. Okay, the graph of the function converges to the line of 0 when n tends to infinity. Clear? Or by any another method, for any fixed value of x. Suppose that any fixed value of x. Suppose that suppose we fixed x between 0 to infinite. Suppose that x equal to 3, x equal to 4, and etc. Then the limiting function fx equal to limit x tends to or n tends to infinite for any fixed value of x, 2x upon n, and when n tends to infinite, then this is equal to 0. It means the limiting function fx equal to 0. This is the limiting function. Okay, this limiting function is constant, fx equal to 0, and also continuous. But when we check the rate of convergence of every function between f1 x to f infinite x, then we find that the rate of convergence of all these functions at the point 2 is different if we check the rate of convergence of all these functions at the point 4 and any other point. Okay, स्टूडेंट, इस फंक्शन में सबसे मेन कॉन्सेप्ट हमारे पास ये है कि हमें रेट ऑफ कन्वर्जेंस चेक करना है. हमें ये देखना है कि इसका स्पीड ऑफ कन्वर्जेंस क्या है. फॉर एग्जांपल यहां पे स्पीड ऑफ कन्वर्जेंस अलग से, और अगर एक एप्सिलॉन जो डिस्टेंस बिटवीन द लिमिटिंग फंक्शन एंड द अदर फंक्शन, any other function, if we want to check the distance between the limiting function and any other function, suppose that distance is epsilon. This is a small number epsilon. Okay, this is the limiting function. Distance between the limiting function and this function at this point, this is epsilon. Suppose that this distance is okay, we can check the distance at this point. Okay, suppose that this distance is 1 2 3. Limiting function and this function, this distance is 3. Okay, at this point. At the point 4, the distance between this function and this function is 3. But at the point 7, the distance between this function and this function, okay, this same function, the graph of the same function, the distance between this function and this function is 1 2 3 4 5. The distance between is 5. Okay, it means the rate of convergence of the functions are different at different point. Okay, in this point the rate of convergence is very fast. In this point the rate of convergence is slow than the point 1. In this point the rate of convergence is something slow, and the in this point the rate of convergence is very slow. It means हमारे पास क्या है, इस पॉइंट पे रेट ऑफ कन्वर्जेंस बहुत फास्ट है, इस पॉइंट पे थोड़ा कम है, इस पॉइंट पे रेट ऑफ कन्वर्जेंस कम है, इस पॉइंट पे रेट ऑफ कन्वर्जेंस और कम है, और आगे जाके रेट ऑफ कन्वर्जेंस क्या होगा, और कम हो जाएगा. क्लियर? इट्स मीन आपके पास 0 to infinity के बीच में सारे फंक्शंस का रेट ऑफ कन्वर्जेंस डिफरेंट है. क्लियर? फॉर एग्जांपल इस पॉइंट पे क्या होगा, इस पॉइंट पे रेट ऑफ कन्वर्जेंस, यू हैव द रेट ऑफ कन्वर्जेंस एट दिस पॉइंट इज 3. Okay, but for same function the rate of convergence at this point is 5. Clear? At point 7. It's mean if the rate of convergence is different at different point for different functions of the sequence of function, then always such type sequence of function is not uniform convergence. Clear? This implies this is pointwise convergence because the limiting function is fx equal to 0. This is pointwise convergence, convergent, but not uniform convergent. Okay, this is pointwise convergent but not uniform convergence because the speed of the convergence at the real line, at the different point of the real line is different. Okay, जैसे कि हम इस पॉइंट पे देखेंगे स्पीड ऑफ कन्वर्जेंस बहुत फास्ट है, बहुत जल्दी से इस पॉइंट तक आ रहा है, इस पॉइंट पे थोड़ा हॉट टाइम लेगा, इस पॉइंट पे हॉट टाइम लेगा, इस पॉइंट पे हॉट टाइम लेगा, और सिमिलरली एट द लास्ट पॉइंट वी हैव द स्पीड ऑफ कन्वर्जेंस इज वेरी स्लो. व्हेन वी अप्रोच 0 to infinite, the time of speed of convergence is slow. It means such type function is not uniformly convergent. Okay, this is another method for understanding the uniform convergence of a sequence of function. Thank you.